Hello everyone. Today we are here for Physics Lab 2 Lines of Charge. The purpose of this experiment is to produce an experimental and computational model for two charged states exerting an electric force on each other and use this model to estimate the amount of charge on each state necessary to float one or the other. The other questions we are going to answer, including these, we are also going to answer the what if and why questions. The fundamental laws involved are the Coulomb law, which basically states that the force between two charged particles is directly proportional to the product of the charges and inversely proportional to the distance between them, to the square of distance between them. And obviously, Newton's law states that the acceleration of an object is proportional to uh, to the net force acting upon it and inversely proportional to the mass. Mathematically, it is F is equal to mass into acceleration. Other concepts in use is that we'll treat the charge tape as a continuous uniform distributed charge, and we'll also use principle of superposition. This is the result preview. This is when we treat the lines as small segments, small pieces of the line, and use them to calculate the electric field between them and the necessary force that's being exerted to keep it levitating motionless. So the magnitude of both forces is 1.4 into 10 to the power negative 3 Newton. In order to determine the charge of the segment of the tape was modeled as several equal segments. Each of them was treated as a point charge with equal charges. Um, the The properties of superposition were applied for each segment of charge by breaking down the tape into smaller equal segments and treating each segment as a point. The behavior of the charges could be analyzed and understood in a much better manner. And assumptions is that we are treating it as negligible. We are also like each tape has same charge density, and dimensions. Charge is not treated as a point charge in the computational model but is treated as a continuous distribution of uniform charge. So this is the experimentation. This is what we get when we use calculations from lab 1. So basically what happens is because we are treating it as a point charge, it is we cannot get very accurate calculations uh, because if you look at the answers here, you can see that the electric force is almost three times smaller than the gravitational force, and as indicated by this graph. This is the coding. Please pause your screen at each thing to look at it. And this is what we use when we use the line charge computational model. Both of them are almost equal. That's what we get when we multiply them. What if and why questions? Basically, the what if and why questions ask why is there a difference between lab 1 and lab 2? In the lab 1, the tape was treated as a point charge. In lab 2, the charge was treated as a uniform distributed charge. The electric field in lab 2 was three times the size of the electric field due to point charge in lab 1. Why are there such discrepancies? The It's because charge may not be uniformly distributed. The calculations are derived using a loop, not integration. So there can be a difference. And then the tape is still divided into pieces, which we treat as charge, which again means that it's not going to be the most accurate result. Thank you and have a nice day.